Okay, so today we are going to start with Hive. So Hive is a part of Hadoop ecosystem to process data stored in HDFS. So it's Hive is nothing but it's a data warehouse built on top of Hadoop. So we interact with Hive by issuing just like SQL-like queries. So what we type SQL-like queries in Hive and then interact and get the data from HDFS. And this SQL-like queries in Hive, it's called Hive Pure, nothing but Hive query language. So why is Hive needed? So the answer for that question is the Hive is needed because the MapReduce, the development of code in MapReduce will take longer. So for faster development, that's why there's a motivation for Hive is for faster development, and also most of the developers can leverage SQL knowledge that became very common. So they can use the SQL knowledge in Hive and run queries against HDFS data. And Hive also allows us to write and start executing MapReduce jobs, and it would take very less time when compared writing the MapReduce job by itself. So motivation for Hive is first is faster development, and then we can leverage SQL knowledge, allows us to write MapReduce jobs. So just like Hive, we are going to see Pig in later tutorials, but this Hive and Pig are developed around the same time frame, and Pig is developed by Yahoo and Hive by Facebook. So this Hive is used to replace like traditional RDBMS based data warehouse tools. So we can use SQL query language and query against HDFS data. So this is little background on Hive. So let's see more on to Hive intro. So what can we do in Hive? So in Hive we can store data in tables, and Hive is a data warehouse system for managing and querying data in Hadoop. So data warehouse for managing and querying data in HDFS. So data is stored like tables. It's not stored in tables, but it's stored like tables, and then we can use query against these tables. So underlying data can be in any format, but for us, when we run it, we can just look at the table and run SQL queries. But the underlying data can be in any format, and it will be in the files in HDFS. So Same SQL concept applies in Hive. Is like it has concepts like tables, columns, rows, and partitions, and it supports lots of data types. But I'll go through the data types in after some time. So this is a very high level. Let me save this. Yes. Okay. Then we will go into the Hadoop Hive architecture. So let's see. Hive architecture. So first, Hive architecture on the high level. Let's draw something. So here we will have HDFS data, and on top of it we will have MapReduce algorithm, and then we will have two things in here. Hive first is driver, and then execution. So, and this, then we will have Hive. Hive QL, and then meta store, and then Thrift server to interact, and then we will have multiple stuff. We can interact with JDBC, ODBC connections. BC. ODBC this, and then we will have Hive SQL-like or Hive web user interface. Okay, so here let's draw this freehand. Okay, so here we have HDFS data in here, and top of it we're going to MapReduce algorithm. Then we have Hive drivers, which executes and submits MapReduce jobs to HDFS. And then HiveQL, this is a query language which we write. And this is HiveQL talks to driver and submits MapReduce job to HDFS. So this is HiveQL. And then we have MetaStore, which gets the metadata to read the underlying file. And then to talk to the outside world, we have something called thrift server. And then this thrift server talks to outside world. But when it comes to Hive CLI, it's connected directly to this. Okay, this is a high-level architecture. So Hive query language, when we write queries, it executes the MapReduce program for underlying HDFS data and gives the queries back. So it's actually both ways. So, and Hive query language relies on the MetaStore metadata. It has all the table information schema it stores in metadata and gets that when we run the queries, it gets the data and gives on the output. And to Hive server can be connected to the other reporting tools like MicroStrategy or Toad and Tableau. So anything that uses ODBC or JDBC connection can easily connect it to the Hive, and we can run queries in that tool, and it executes the queries in the cluster, submits MapReduce job HDFS, and gives the output in that tool. So we can say something like this. So reporting tools like Tableau, MicroStrategy can use SAS, R, so these are reporting tools that we can use to connect to the JDBC. So this is a Hive architecture. This is how it works. And for Hive, there is something called Hive command line prompt, which we directly write it, deal with HiveQL. It's nothing to do with Hive thrift server. This is only needed when you're connecting to the JDBC or ODBC for the outside world. But Hive CLI, Web UI, both it's on cluster. You run commands and it gives you the output. So this is the architecture. So let's save architecture and then save, and then we'll open new one. Save. Okay. So we have seen how architecture works. So let's go to. So in architecture we saw Hive submits. Hive uses HDFS for storage, MapReduce for execution, and RDBMS metastore for storing metadata. Let me open it. So open that install. So Hive uses HDFS for storage, MapReduce for execution, and this metastore for RDMS storage. So these are the components, and the client components we call, this is called Hive CLI, a command line interface, and this Hive web interface. And also Hive optimizes all the queries that we submitted here in HiveQL. It optimizes and convert it to the MapReduce jobs and run it against the HDFS. So so this, we have a driver and execution that executes the job for interacting with Hadoop, and this metastore contains the schema and other metadata. So let's go to, so Hive principles is its schema on read. And when I say schema on read, so it actually doesn't throw any error when we are writing data into Hadoop, because it doesn't matter, we are writing into HDFS data. So it doesn't in RDBMS, it's mostly on schema on write, and if you have any error, it throws an error while writing the data into the RDBMS data. But Hive principle is schema on read, so it doesn't worry when you write data into HDFS. But when you are reading from HDFS, that's when it compares with the schema, and it throws an error when we are reading the data. So that's why the Hive principle is schema on read when compared to RDMS, which is schema on write. And Hive uses serialization to read and write data. So it uses serialization and deserialization data. So serialization is a process. So what it does is it turns an object into series of bytes and stores in a different format. And then deserialization is while reading the data back onto data back from HDFS. So serialization is nothing but it's converting the object type into the different file formats that's given. I'll go through the different file format that we can use in Hive, but for now we can think it's that serialization is nothing but saving the data into the file formats, and deserialization is nothing but retrieving those data and reading the data. So I'm trying to, okay. So for serialization and deserializations, currently what's available built-in serializations are, serializations is also shortcut for SERDES. So we can call it as SERDES. So the file formats that it supports are Avro, ORC, regular expressions. These are built-in file formats, and Parquet and CSV. So yeah, so uses deserialization, read and write data. So built-in SERDs are Avro, ORC, Park, CSV, and we can also write custom SERDs depending on our requirement. So, and this is serialization. So in Hive, what we have is it consists of we have databases, tables, partitions, and buckets. So we have this 4 in Hive. we can use database, tables, and this partitions concept and buckets concept. I'll go through partitions and buckets in later tutorials. So in Hive, there are two things one we have to understand is one is local Hive data warehouse, and then in local Hive data warehouse we have managed tables which are managed by Hive, and it's usually stored under user Hive. I'll show all the practicals in next 5 to 10 minutes. First, let me go through the architecture, and then we'll jump into practicals. So this is local Hive data warehouse. So managed tables by Hive, and it's stored in user Hive warehouse. And then this managed tables, when we drop managed tables, it drops schema and data. This is local and it's called managed tables. And there is something called external tables. So in external table, Hive manages only metadata. So data can reside anywhere on HDFS, and also it drop table, external table, remove data and data and schema. So two things in here. So Hive has a local Hive data warehouse which is called managed tables, and something called external tables. So in managed tables, it's managed by Hive and it's stored under user Hive warehouse data by default, and we can also change this location, but by default it's user Hive warehouse. And if we drop managed tables, it drops schema and data. But when coming to external tables, if we create external Hive table, it only manages metadata, and the data can reside anywhere on HDFS. And when we drop external table, it will remove data and schema. So in Hive, what we see is data, it can support multiple databases, so that you can see supports multiple databases, so that multiple teams or users can create their own databases, and it supports multiple databases. So you can create so many databases in Hive. And when it comes to, then we have tables, and then we have partitions. So partitions are nothing but each let me write it down. So each table can be divided. So it can be divided into multiple partitions. So this is we needed to improve performance. So if you have large volumes of data in a table, and if you divide it into partitions, then Hive can go directly to that partition to query data. It doesn't have to scan the whole table. So this partitions is like a virtual column, and which can be used like any other column. So mainly partitions is needed for us to improve performance. So a table can be divided into multiple partitions. So let's say if we have a date as partition in this table, so that table can be divided into multiple partitions, so that for every date we will have a folder existing in HDFS. So if you have a date today, so it will have a folder and a partition is created, and under that partition we should keep the data only related to that particular date. So or let's say if we have a partition by country, so we can do it will have multiple partitions divided by country, and every partition which has a country has a related data, corresponding data. So this is again and we have a concept called bucketing. I'll go through later. So okay. So let's go through Hive data types. So Hive supports data types, most of the data types that we use in RDBMS. So it supports big int, which is 8 bytes. It supports int, which is 4 bytes, and it supports small int 2 bytes and int, which is 1 byte. And it also supports floats. It also supports Boolean strings, and in new new version of Hive, it also supports char and varchar also. Apart from these three data types, there are other apart from these data types, there are other complex data types that Hive supports, like maps, which are nothing but a collection of key value pairs, and it also supports arrays, which are nothing but lists where or elements of same data. It also supports structures, which are nothing but complex types. So this is what Hive supports. So the string char and varchar are recently added to the new Hive version, but prior to the new version, we used to have big int, small int, float, Boolean string, and these are complex data types, which are maps, arrays, and structs. So okay, so let's jump with practicals. So now let's jump to practicals. So before creating tables or anything, let's just query how to, I'll show you how to enter into Hive and do a simple select queries. So to go into the Hive CLI command, all we have to do is just type Hive and it will take you to the Hive CLI. So now we are in Hive CLI. So here to see the databases that we already exist in Hive, we can we can see show databases and it will show you what all databases that we have. So we have 3 databases and it shows you time and fetch records. Now we can go into the database called Hive underscore tutorials. So we can say use Hive tutorials, and then here you can see tables. You can type in as show tables. So it's the same same queries that we use in RDBMS. It's show databases, show tables, and use database. Let's run a simple query in here. Let's select star from, let's say, airports. So it's giving the same output like we normally do in SQL, but it's just giving it on a Hive CLI command. So let's run. So we can let's run. If we do select star from database, the data it's giving, it's not normally doesn't submit the MapReduce job. But if you want to see a MapReduce job that Hive submits, we have to select one or other column. So let's see. To see the database, to see the schema for the table in Hive, we use describe and then table names. So this is how you see the you will type in describe and the table name, then you can see the schema. And to see the table create statement, you can see show create table and then do select. So it will show you create statement also. So now let's get only 2 columns, name, IATA, from, airlines, limit 10. So I'm getting name, IATA, from, airlines, and limit 10. So we got this one. So we can also let's do count of star from. So I did count of star from airlines, and you can see it submitted MapReduce job. So it will tell you how many mappers and reducers it's going to submit. So it says launching job and number of reduced tasks. It's assuming as 1, and it will this URL will take you take you to the front end URL. Will show you the job got submitted, and you can see the more details if you go to this link. Let's go to the link and see. Copy. See here, mapper 0, mapper 100% completed, reducer still not started. So here you can see MapReduce application from the front end. This is a GUI tool to see the job logs and job details. So I just copied that link and pasted in here. It will show you what job ID it's running and what is the query that you're running and its state it's running. So to dig deeper, we can click that job ID and it will show you more details like mappers, reducers, application. So these are our common stuff, and it will show you how many mappers it submitted, 1 mapper, and it will show you how many reducers it submitted, it's 1. And then we can go into that particular, actually we can go to the maps. Sorry, let's go to the, if you want to see details of how mapper is running, you can click that and it will take you. And if you want to see any logs, this is where you see logs. If you see any issues or if the job fails, you can click to that mapper. It will go to this logs and you can see the mapper. It will give you all the details. It will give you all the details. This is for mapper. Same way you can go to the reducers and you can see log files, and it will show you the complete log details. So let's see. Okay, so it's completed and the output is here. So we did a count of star from airlines and it's completed, and this is here. So until now we saw select command for Hive, how to go into the database, use database and everything. And I want to show you something also. In Hive we can interchange the constructs. When I say interchange, I'll show you an example. So I'm going into Hive. So let's see. So what does Hive supports? Hive supports, we can run select queries, like we can do select column 1, column 2 from table. We can use where condition, and we can use limits, where conditions, and you can use limits. So in here Hive also supports interchangeable constructs, which means that the same query can be written in this way. From, we can say table and then say select column 1, column 2, then do where condition. So this is what called interchangeable construct. So Hive supports interchangeable construct like this, and also we can do these things
And so what's the use of this interchangeable constructs? Like, where do we use it? Like,
Yeah,
how
so
is it useful?
the reason where we use interchangeable construct is, so when we, let's say if we have a select query from table, and if you want to do inserts into multiple tables, so instead of writing multiple tables in here, what we do is we do only from table once, and then we insert into table. Let's say our requirement is to insert, we have to create two tables, one with a condition we're saying that country is USA, and we have to create another table where we say country is India, and those all the data is in a table called table 1. So we don't have to type table 1 twice. We can just read that table once, saying that from table, and then you can do that insert into table 1 where country is USA, and then immediately we can write another insert after that, insert into table 2 country is India. So that means you don't have to write the table twice. So for that kind of scenario, we use interchangeable construct.
Okay.
So that's select query. So let's go and let's do some database coding. So this, let's say save as code.
And also, like, when
Scoop and Hive both are different. Scoop is used to import and export data from RDBMS, but Hive is used for applying transformations. So Hive cannot import or export data from RDBMS, or Scoop cannot apply transformations on the tables. So there are two different components used for two different requirements. So if our requirement is to pull some data from external RDBMS sources into Hadoop, then we use Scoop component to pull the data from RDBMS and put it into Hadoop. And after getting into Hadoop, if our requirement is to apply some transformations on the data, get some calculations on the data, or clean the data, or create multiple tables for using a reporting purpose, then that's where we use Hive. So the data can be any HDFS data. It can be a data scoop data also. So we can just take the data, apply transformations on it, and create smaller tables, and then give it for users for reporting purposes. So that's what it's used for. Both are there for two different reasons, and we need both.
so we can only import or export only through Scoop.
Yes, for only from RDBMS,
Okay.
Scoop is used. So Scoop is a tool to import or export from RDBMS data. It's not used for anything else.
Okay.
So let's go and just do simple queries. Actually, let's go and do let's create a database. Create okay, create database. We can say training, and we can do multiple stuff. So if we want to check before creating this database, if we want to check if the database exists or not, and only create if it doesn't exist, then all we have to do is if not exists. So create database, if not exists, then create database and call training. So it created. Now you can see show databases. It created that. And same thing, if you want to do drop database, Actually, you can use the same thing. If not exists, training. It dropped it. Not sure why it says not expecting AWS.
Maybe we should say if exists.
Yeah, let's say, yeah, let's do that. Okay, then drop database. Yeah, right, you're right. Thanks, guys. So yeah, drop database if exists training, and use create database if not exists training. So this is a simple create database and drop database. So let's go ahead and create this, and then we will use this for creation. So so let's wrap up our class for today, and then we will next classes we will see creation table, create statements, insert statements, creating partitions. So